Hi, welcome to Project Geospatial. I'm Adam Simmons, and we are here at the Geoint 2023 Symposium in St. Louis, Missouri, and I have the pleasure of being at the ICEYE booth. So here with me is, go ahead and introduce yourself, please.
So I'm Eric Jensen. I'm the CEO of ICEYE US.
Okay, great. Can you talk a little bit more about, how you got involved with the industry?
Sure. Let's see. Web applications, I'm a native St. Louisan, so it's always great to be back in St. Louis and see the investment that NGA's been continuing to make in the city in a more, I would say, overt way as of the last several years, especially as it relates to K through 12 education and the kind of tailored Geospatial Institute, investing in college degrees and that kind of stuff. That's just awesome for the community. So it's adding another layer of vibrance to what already is an amazing event. So I started in the Midwest and then headed out to the West Coast to begin work at one of the big defense primes out there. Worked in kind of, I would say, adjacent to some of the geospatial stuff that you see at the conference. Joined ICEYE back in 2020, really inspired by the team, the technology, the business model, and the timing, and thought that this is the type of capability that the kind of allied group needs to have. And so been privileged to kind of see the company grow globally to over 500 employees. And in the States, my job is to kind of lead operations stateside writ large. And we've grown from 2 of us back in 2020 to over 50 now. And we're operating a constellation of tens of satellites. We're building and launching more than 10 a year. And it's been a great run with a humbling reception, no cost the end users.
Great. Well, let's touch a little bit more in detail about the capabilities here. You already mentioned how many satellites, right? In terms of revisit rate, what are we looking at?
So we've launched 24 satellites to date, and kind of one of our claims to fame is being the commercial operator with the best revisit around the world. And we fly our satellites in a polar fashion, so they orbit from south to North Pole and back again every 90 minutes. That enables us to have varied revisit depending on the latitude. So at the poles, sub-hourly, and at the equator, single-digit hours today is what we can do. So global coverage with, no worse than, let's say, hourly revisit anywhere in the world.
So resolution at Spotlight?
Resolution Spotlight, best we do now is 50 centimeters.
50 centimeters. Incredible.
It is incredible. From our dishwasher-sized form factor in space, our phased array antenna is doing great work.
Excellent. So what can you tell us about, in terms of, collection is one thing, but what else is unique about ICEYE? It's a new company. You've been around for a few years now, but compared to the traditional guys, you've been around, you're fairly new to this space. So in terms of, I'm sure you've also helped revolutionize how to manage all this data too, in terms of distribution and ordering and delivery, right? Can you talk about that a little bit?
Absolutely, yeah. So I'll think about it kind of across the whole value chain. So if you start at the beginning in terms of the remote sensing value chain, you've got the sensor creator or the bus builder. And oftentimes the traditional approach was to have 2 independent firms build both of those systems and bring them together, integrate it all, fly it, and hope that magic happens. And that used to, in the traditional sense, let's call it like 15 years ago, that would be a multi-$100 million process that took 4 to 6 years for a single satellite. And those satellites were hugely capable, and some of them are still flying today commercially and provide great service, great geolocational accuracy, that kind of stuff. The thing that ICEYE did to really kind of achieve a new strata in the industry as it relates to SAR was to miniaturize that approach. So maintain the same performance for 10x less the cost and 3x the speed as it relates to starting a satellite build to deployment. And so the core ethos of our company is that we build our system kind of like you think about building smartphones. So the hardware is just the host for the software. And that wasn't the way that satellites were really thought of in ages past. So when we launch our satellites, there are software-defined satellites, software-defined flight software, software-defined radios. So we can update the system's performance and its collection ConOps and its daily yield even over a given region, in addition to the products that we allow it to produce pretty much on the fly. So that's a very unique and different approach to satellite building, generally speaking. And so the miniaturization of the technology, the proliferation of the constellation, the cost effectiveness, the speed, There's not really one element that you can point to and say, like, this is the thing that's being done way better. It's a collection of things that have added up to much more utility. And so as we look at the system and how it performs, I would say our specific design point, being that we're a phased array, allows us much greater flexibility from a small form factor satellite in terms of the collection cutoff. So we can do both high, wide area collection, 100 by 100 kilometer collection, all the way down to at lower resolution. And on the other side of the spectrum, so to speak, much higher resolution at a smaller area. And so from a small satellite being able to collect with, I would say, maritime mission applicability was really not something that was done with SAR until ICEYE did it.
Perfect. Now, can you talk about, a lot of the discussions today at Geoint, or even the last couple of days, put some interest out there for how the collectors put forth their collection strategies to help out their end users, maybe specifically the government. Can you talk about maybe some strategies to help evolve your users, help find imagery or task collection based off the objects or even the facilities of interest that they might want to order around?
Sure, yeah. There's a couple of comments on that I think that are relevant. One is the accessibility of the data, generally speaking. We're transitioning to a mode, the industry, where all providers of data streams from space and different modalities are looking at portals and APIs as kind of the de facto table stakes, so to speak, to serving end users. So in the future, what we're trending towards that fantastic future we've always talked about, which is no one's going to be looking at imagery anymore. It's going to be just APIs doing all the work, and then the intelligence outputs being the things that people use to make decisions against. I think that's still a few years off, but we're headed the right direction. So the things that we do to enable delivery efficiency are along those lines. It's all about like archive accessibility, portals, APIs, that kind of stuff. As far as SAR specifically, one of the mystifying things about SAR is that, to the lay analyst, it seems to look like a panchromatic image. And so if I have a high resolution SAR processed scene, it looks a lot like a panchromatic black and white electro-optical image. So,
as we can see behind us.
Right, so comparing the two of those things is only natural to do. The difference with SAR is that the richness of the data set is non-obvious.
Yeah.
And so one of the things that ICEYE is doing and has done, and the new product we released this week, we call dwell mode, which is essentially, it processes the microwave pulses that the satellite receives when it sends them down to the ground and they bounce back off the Earth. That's how a SAR system works. It automatically colorizes those features on Earth that are man-made based on the reflection potential of the microwave pulses that hit those man-made features versus the surrounding natural environment. And so for both advanced users and maybe those users who are less familiar with SAR, it gives them like a visual cue that there's something that we should investigate more in this scene that we didn't maybe know was there. And so the security applications of that are highly varied and very strong use cases for SAR being more broadly adopted writ large.
Awesome. Well, I appreciate giving your insight to that. As we wrap up, I want to ask you, do you have any words of inspiration to give young people who maybe don't know that this is a really awesome path for their careers?
Yeah, I think one of the most amazing things about the Geoint sector and remote sensing in general is that it requires a high degree of technical competence and a high degree of kind of understanding of things like orbitology and photon level physics and light physics and electromagnetic spectrum type stuff. And so there's a lot of the things that generally speaking seem a bit out of reach at face value.
Seem intimidating the way you just pulled it.
However, the cool thing is that the applications of those advanced techniques and advanced engineering principles are so visceral that any lay user can look at the impact that they're having on a day-to-day basis and see what's going on. So when we talk about kind of our vision as a company, it's all about improving life on Earth by providing that source of truth from space that enables better decision making. And
that's a good slogan right there.
People thrive on that. And that's why, that's the subconscious attitude that people have when they come to our office every day. They know they're making a difference and they see the fruits of their labor, and what they're doing is hard, but nothing good in life comes easy.
Yeah.
And why not work on something where you're actually promoting a positive outcome for society with better transparency? You're addressing natural catastrophes, you're solving hard problems, you're doing it from space. And so to me, it's an awesome opportunity to apply and work super hard to accomplish the mission.
Awesome. Well, thank you very much for joining us. Give us some insights into a snapshot of who ICEYE is now, and I look forward to seeing what you turn into in the future. So, thank you very much.
Thanks.
I'm Adam Simmons with Project Geospatial here at the Geoint 2023 Symposium, and we'll talk to everybody next time.